Okay, welcome. Our second October meeting, I think, of the working group on computational political science for democratization. And so we have a team that is growing. There are now 10 people on our team on this project that's designed to try to build an AI platform to understand democratization. Let's finish the slide. And this is an overview of what we're going to do today. Molly's going to talk about the motivation for doing this, like why do we think that it's possible to do something like this? We're trying. Dimitri's going to talk about some of the limitations. I'm going to talk about some of the characteristics of data that we're working with, and how we conceptualize things, and then how the structure of the data makes some things easy and other things very hard, to point out what the challenges are. And then Rick is going to make a demonstration of beginnings of a portal that will be hosted at the Lucy Institute, and Dimitri will talk about future developments. And then I have some comments about developments about the public portal, and then I'll talk about some future developments in our project overall. So turn it over to Valia.
So the biggest motivation for this project stems from the controversy where people who work in social sciences, and that's both sociologists, especially those who work on the broader societal issues, and political scientists generally seem to think that social phenomena cannot be predictable, that human behavior is so complex, and there are so many different processes that underlie things like democratic change, or regime change, or protest movements, which occasionally seem to be spontaneous, like the Arab Spring was, right? So there was this Facebook post that just, ignited the fire. And then we as social scientists cannot possibly understand all the complexity. So the argument that we are trying to make stems from the fact that social processes don't exist in isolation. So the societies in which we live, they have different economic foundations. And social processes are inherently tied to economic processes. One cannot be without another. It's very hard to have democracy in an impoverished country where only the top 0.1% reach in the entire country is poor. That will not be democracy. And it is easy to have protests in a country like that. Right? So economic and social processes are tightly related. So the indicators that are needed is a subject of a lot of work, but we are basing some of our early analysis on an earlier project. The project is very old by data science standards. It was completed in July of 2018. The project was commissioned to us by Volkswagen Group that wanted to predict the entire Russian automotive market for all the new cars to be sold monthly for the first 3 years and annually for the remaining 7. And it's not as big of a market as the United States, but it's still a respectable size of 1.5 to 1.8 million vehicles a year. And they wanted predicted by type of vehicle, by brand, by make, model. And we had literally hundreds and hundreds of models predicted down to every level. And so what we had to start with is we had very good data on the cars sold up until this point. So they were providing us with proprietary data on all the brands and all the makes. Everything else was up to us. So we started with a very large database. I don't remember, it was hundreds of variables. I think at the end of the day, we ended up with just 128. And it's not that many when you think about the complexity of the project. And we built a forecast that looked like something over there. That's already a stabilized forecast, which actually didn't move up and down. My biggest problem, so at that time, neural network models were just coming out. We had to program our own neural network. We had to incorporate vision elements into it because base month sales are so dependent on the prior month sales. And if you're sold out on the lot, you're not going to sell again. So things like that. So we have to update the priors all the time. And no matter what we did, we saw this general trend. Obviously, it's highly seasonal. It's also highly cyclical process, but the forecast kept moving up and down and up and down. And because I don't understand enough about cars, I also don't understand enough about social processes. When I looked at that 15-year trend, there was very clear 5-year intervals. You see that, right? So there's one that has a U shape, then another one that has also U shape, but not as pronounced. And then the next 5 years flat. And in my infinite wisdom, I said that, well, that's probably because people change cars every 5 years. So you're seeing the cycles. People bought the car in 5 years, they changed the car, and then people just laughed at me because that's not how those forecasts work. So when Dimitri looked at that, he said, you don't have a 5-year cycle. What you have is you have an overlay of political cycles on that. Because Russian economy is very highly dependent on the political situation. We have state government or state Duma elections every 4 years, and we have presidential election every 6. And every time there is an election, even in a country like Russia, there is a potential, at least for regime change. So there is a lot of economic processes that happen to keep the existing people in power. So when this 4 and 6 years overlap, that's what gives you that 5-year years. So he coded all of those elections. I put them in as them variables, and their forecast stabilized. So no matter what I did to the model, it stayed stable. And it stayed stable, and it actually became exceptionally active. So there is some forecast accuracy. We delivered the model in July. So when you see as actual and forecast, it's not training and validation. It's we delivered the forecast in July. The next numbers in August, the actual sales versus what we have forecasted with the model. So we were off by a couple thousand out of 135. In July, we are off by about 1,000. In August, in September, out of 146,000 sold, we're off by 36 vehicles. Overall, the forecast remained very accurate with 98.6 accuracy rate in the course of a year. And then COVID hits. And they call us and said, well, what do we do? It's March. The whole world is shut down. They're shut down. Like, how am I supposed to do COVID? So I tried different ways of stopping the economy entirely. And so we played with this model. Said, you know what? I cannot do this. No matter what I do, it's coming in at the bottom point, which what the forecast actually was. And that December, when the world reopened, they did call me back and said, you were all by about 5,000. So the forecast remained stable, even with something like COVID. So the best part about this is when we were in typical forecast is a hockey stick, right? So it's kind of going straight and then goes up. Well, there's a huge drop down, like huge. And when Volkswagen people ask us, what is this? How do we present to our board of directors? Like, we have no idea. We don't know why it sharply drops. And I mean, it drops by a sizable amount of vehicles. We have no idea what's going on. We couldn't explain. We didn't know where to look. And they said, well, we'll show the next 3 years. Remember, it's 2018. We'll show it until 2021 or 22. It looks good, and then we'll just worry about, we'll say, it's too far out. Well, the war starts, right? And the sanctions come in. And people now tell me, well, in retrospect, you can say this was the war. Well, we actually went back and looked at what was happening in the economic data, why it was predicting such a sharp drop, and then slow recovery, right? And turns out that because our model had so many economic variables, among them metals, most importantly, rare earths, and a bunch of different variables that would be important for producing cars, these variables also turn out to be important for producing bullets. And these are mutually exclusive. If you're producing bullets, you're not producing cars. So what happened is over a period of 10, 15 years, the metals were slowly taken out of the economy, to the point where by about 2022, there was a sharp decline in production because there was just not enough. So, I mean, if you continue that trend of taking those metals up. So Putin was planning for the war for a long time. It wasn't that he decided woke up one morning and decided Ukraine is not a country, right? I'm going to go attack them. No, he was planning ahead. So the economic model was so tightly integrated with social processes that you could actually see that. And so we got very excited. Well, it looks like we can, what if we flip this? What if we have economic data and we predict social data? Because we have the social processes, a political process for stabilizing an economic forecast. And so that's pretty much has been our work. The models have become a lot more sophisticated since then. When I look at this model, it seems like a child model now. Now I think, right, ChatGPT can do better, but I think even college undergrads build better neural networks. At that time, it was state of the art. But we did publish paper for market applications for market development forecasting out of this work. We couldn't publish it for a long time because it was under NDA for I think at least 3 years. But that paper has come out, and we are continuing to working on improving these forecasting tools because now the goal. I mean, we know we can predict economic phenomena as complex as automotive market for the entire country. Now the question is, can we flip it and using economic data see what's happening with social processes? So that's kind of where I come in with motivation. Did I say everything then?
Yep.
Okay. Wow. Well, I know nothing about social process. Okay.
Okay, so why we are decided to switch this or just to use not the same but a similar methodology to forecasting complex social phenomena? We faced with limitations that exist in literature and that we kind of quite aware of. And this is not the first actually attempt to forecast or model with predictive modeling here complex systems. Each time we have some fashion to some things like big data or machine learning, near popularity or attempts to forecast this kind of things emerge. And the last was in the beginning of 2000s, I think, when there was a fashion about big data, first of all, machine learning, and some forecasts were produced mostly of international conflicts and wars. Or international conflicts mostly, and not only inflation, but I'm looking to that to the civil, revolts and coup d'etat and all this stuff. So, and after this, there were some literature about the critics of using this kind of thing to predict social phenomena. And there are several problems and limitations. First is about complexity and contingency. So the phenomenon is very complex. By complexity, we told it during the first seminar, we mean to it. There are not only linear constructs of the variables, so there are latent variables, but also that there is interdependence. So you can, in the same time, some causes can become an effects, causes consequences, and so on. So causes consequences are not very, how to say, clear what causes what, and everything is dependent from everything. We hope that with AI, with this next wave of interest and next wave of passion into AI, we can do this by incorporating complex data. But I'm just running ahead. On my opinion, the most important thing to tackle all these limitations is put on the first place theory. So theory-driven thing is the first thing to do to tackle these limitations. Data quality limitations, of course, exist because there are different data, even if we are facing with country year data that exists in different places. Even this quite established data sets, they have the issues, they are not combined with each other well. There are a lot of missing variables. So actually there are a lot of problems with country year data as well, including representativeness. So not all countries have a long time series data because some countries just don't exist for a long time. And we are trying to solve these problems with the careful approach to data curation and using semi-unstructured data like GDAT. Theory-driven, this is what I said. So most of the previous attempts were theory-free modeling, was most important critics to these models. So we want to do theory-driven, put it on the first place, and then data-driven approach. So both theory-driven and data-driven approach are more important, but data-driven approach have to be informed by strong theory. And Michael Kopic is everywhere our leader, but first of all here. So knowledge graphs, this is here kind of new thing in this wave of AI development. We have some thoughts to how to integrate AI to provide more insights on existing theories, actually. So to combine machine with humans to understand better theoretical backgrounds behind this democratic development of design. Consideration about time and space are important. So, and there are a lot of problems here and critics that units of analysis can be different, that territorial change occur a lot, that the different treatments of time periods, locations. What I didn't say actually is another thing that was a lot of critics, that when you create, for example, a model, very famous model of gold state of political instability in 2009, if I'm not mistaken. So a lot of critics was that this model was not stable in future. So it predict well till 2009, for example, but in 2010, about 12 something occurred and model just was not accurate. And problem here is with time, with space, but also with these variables that was documented as, for example, independent become dependent. Some new variables were most important that was not included into the models, and even more interesting things that some variables start behave differently in different time periods. So again, we hope that these large AI models can handle this. With long time periods, multiple locations, can do it simultaneously. And temporal variability and stability, this is what I was talking about, but as hosting example. Actually, with this, what Valis explained during the first seminar, this is the self-learning of this new, better self-learning of this new AI models can deal better with this situation, with this cold stone problem. So this is it. So just the one slide to share with you that we're quite aware of the limitations. And our project.
Thank you. Okay, so as you see, we have kind of a large team. Several of us are here. Donald in the back, and Jacob Miller is on Zoom. Anyway, so our goal, as we said before, is to build an AI platform that's going to model democratization, which we conceptualize in terms of levels of democracy and positive changes and negative changes in democracy, upturns and downturns. We hope that the models are good enough to make some, at least near-term forecasts that could be useful, and also to be able to simulate different what-if scenarios, like what would you expect to happen if Republicans win the next election, or what would you expect to happen if there is a coup in Mali, or something, what are consequences of these things down the line. And also, you could use this to make best case scenarios and worst case scenarios, depending on what conditions are there. A lot of the data that we're going to use, at least from the foundation, at least for measuring democracy and things in democracy, is VM data, which is nice to have because it's relatively new and has a few hundred variables that we can rely on. But VDEM also measures some democracy adjacent concepts, things like corruption and the rule of law, sovereignty, things like that might be relevant. We also want to integrate some variables that are approximate variables that are very dynamic, things that change in the short term and have a plausible connection to changes in democracy, like short-term economic performance, civil society campaigns, wars, natural disasters, events that GDELT codes. This is a big project that Google has that codes event data on a 15-minute interval every day around the world. Leadership changes, mass sentiments, things like that might matter. But there are also some intermediate variables, things that either change slowly, incrementally, or change episodically. Like they might be by episodic, I mean, they remain pretty stable for a period of years and then suddenly change a lot and then are stable for a while. So those include things like GDP per capita or education or industrialization. Those are more incremental. And there are also some very distal variables like geography, ethnicity, climate, resource endowment, things that don't change much at all. I mean, climate does change, but very slowly in the scheme of things. And those things we think we can pretty much treat as exogenous, like they're outside the system and they're driving things. So this is the next slide. I guess it is. So we're taking an innovative approach. We're using theoretical guidance while exploring data, and we're going to try to reduce the complexity of the models by engaging in data reduction where we can. That is, we might have 12 variables that measure approximately the same thing, and then we can use something like backward analysis or principal components analysis, combining into an index that measures the larger concept better. But the kinds of models that we're trying to use for this, and Valia should really be the one to talk about this, are two kinds of neural network models. Neural additive vector autoregression, which is really kind of aggressive exploration of structures in the data to help uncover what are the right mixes and combinations of variables and lags and interactions and things like that that might be useful for explanation. And then TDNR, the network vector autoregression with time-varying nodal influence, which, correct me if I'm wrong, but I think this allows the model to be different for different times and places. Different conditions might allow the model to adjust to different conditions around the world. Another thing that we're doing, which I think is the first time anybody's really done this, is to treat democracy not as like this thing that's out there that we observe and measure, but as an emergent property of a complex causal system. That there are many components of democracy, and instead of being like attributes of democracy that we measure and then aggregate, this is a causal process. That there are causal relationships among elections and civil liberties and judicial independence and civil society activity and all kinds of things like that. They are locked together in causal relationships. And democracy is what emerges from the interaction of all of these things repeatedly over time. And so part of our AI, part of our neural network will be looking at these relationships among the moving parts of democracy and also relating those things to the things that are on the periphery of democracy and things that are more distant from democracy, connecting them all together to estimate all of these relationships. And we're also going to incorporate the GDEL data, which has very fine-grained data on events. Most of the data that's been used for modeling democracy has been country year data. And that's kind of a hindrance when we're trying to forecast things because things happen in between January each year. So we're hoping that we're even going to have to aggregate GDEL data. I'm thinking maybe aggregate it to the month level so we have maybe monthly data on events that are happening that we could use to adjust predictions for coming years. And that's available since what? So 1979. Also, people when they model levels or they model change, they tend to model these things separately. But we are planning to integrate or combine models of levels of democracy with levels of change in democracy, upturns and downturns, all in one model. And we also are designing this to be interpretable. And I wanted to check this with you, but I think that the model will still be sort of opaque in terms of how did it come up with this answer. But the answer itself will not be opaque. It'll be transparent. We'll know what the relationships are that the model comes up with, even though we don't really know how it got there. Okay, so I wanted to say something about what's easy and what's hard to do. What are the, show some data. So this is measure freedom of expression, one of the components in the democracy measures for most countries for 125 years. And as you can see, so we have the previous year level on the x-axis and the current year level on the y-axis. And as you can see, most countries don't change most of the time. In fact, free expression in any year is on average 98.6% of what it was last year. And this sort of explains in an opaque way, 97.6% of the variance. So there's strong inertia built into democracy data. And that's important to know, and that's kind of useful. Why is there strong inertia in the data? I'm not going to go through all of this slide, but I just want to say that it's not because inertia is a theoretical concept. It's because there are powerful forces that tend to reproduce the same political system over and over and over and preserve the way things are. And those are a function partly of some static, deep historical conditions like geographic location, ethnic mix, religious mix, colonial legacies, etc., that happen once and then they don't change much after that. They leave a legacy that lasts. But there are also some other conditions that are powerful that change slowly and incrementally, like class structure, per capita income, income distribution, the size of the state, education, religiosity, immigrant population, etc. They change, but they don't change a lot from year to year. And these factors are important to have in the model because they help explain why some countries tend to be systematically very democratic and other countries tend to be systematically not very democratic. But we turn to this graph, you see that there are points that are off the diagonal. So what that means is that, we could predict with a high degree of accuracy many of the points in this graph. But sometimes we would be just terribly, terribly wrong about the major changes that happen. So there are major changes that punctuate the equilibrium that's in there. Why does that happen? Well, this is before the why. Just illustrating this, the within country change. So this is like change in freedom of expression last year versus change in freedom of expression this year. And that's much, much harder to explain. So there's a relationship. You can say that the size of the change is on average 21% of the size of the change last year. And then if you spell that out, and next year you like square it, cube it, etc. So after 2 years, it's 4% of what it was. After 3 years, it's 0.8% of what it was. So it dampens, it dies down very quickly there. We also see in the graph that big positive change is rarely followed by big negative change. So there's not much in the off diagonal. But these tendencies only explain about 4% of the variance and changes. So change is really hard to explain. What might explain this? Dynamic conditions are the leading candidates for this. Things like economic growth, inflation, natural disasters, pandemics, protest campaigns, election outcomes, leadership, etc. And also episodic changes like war, civil war, revolutions, technological development, things like that. But even with these many hypotheses, it still remains very hard to explain. So what does it look like for a particular country? There's Brazil, in case it's familiar to many people in the room. And this ribbon shows both the current value and the lag value, the 1 year lag value of this. And so that the ribbon's pretty thin. And it shows you that just knowing the lag value would help you predict these trends in Brazil really pretty accurately. But the gaps between them are what's unexplained. So it's really the vertical gaps in this year and last year that are really what we need to explain with change variables. So a good model, a model that would improve on just a lag dependent variable, would make predictions that are somewhere inside the ribbon in this vertical distance here. So how well can we do without AI? Here I estimated a model, a panel model that has a whole bunch of dynamic variables in it. And I'm not going to go through the whole list, but just the idea is that I put a bunch of stuff into the model to try to explain these dynamic changes. And then I put the predictions of that model in red dots here to see if they're inside the ribbon. And sometimes this model performs better than just a lag dependent variable. So if you look, I don't know, here and some of these things, that's a nice hit. But sometimes it explains no better than the lag dependent variable and when it's on the right edge of the ribbon. And sometimes it's outside the ribbon altogether. So sometimes it just doesn't explain much very well. And another way of looking at this is instead of putting levels of freedom of expression, I put changes in freedom of expression on the y-axis, and then this is time as well. And so you can see the periods where the big changes happen. There's the coup of 1964 in Brazil. There's a period of liberalization in the late 1970s. Then the transition to democracy, the mid 1980s, then pretty stable. And then in the Dilma and Bolsonaro governments, there was some decline with some recovery after that. So, but the point here is that in periods of stability, a simple model would predict this pretty well. But in periods of change, the predictions of this model are usually belated over predictions. That is, after the change happens, the model says next year, okay, that happened, so now I need to catch up with that. So it's always playing catch up with the change that happened last year. And it tends to kind of exaggerate what happened there. And so if I put the predictions of the model against the actual data for this, the R-squares, it's a little bit better than just a lag dependent variable. It went from 0.044 to 0.074. A little bit better, but still not good enough for that. So that's a problem because the most interesting things that need to be explained about democratization are the changes. And especially if you wanted to have any kind of useful forecast, you really need to explain the changes. And that is hard. So Dimitri's already covered much of this, but there are several things that we could do in AI that would not be done in a typical panel regression model. Like doing a better job of searching for things, including some measures that are inside democracy, which I think is very helpful because most of them are pretty tightly correlated with each other. So there should be strong relationships there. We can integrate the model for levels and change, and we can incorporate some within your data. So then I'm going to turn it over to Rick. This is Rick Johnson, the Lucy Institute.
Yeah, I was going to make you all those I've met yet. So a bit of this is, oh, there we go, left button, got it. So the AIM3D portal is building upon a data platform, larger data platform that we're building within Lucy that is really focused on kind of these 5 main things where it is telling data stories, so visualizations, having a way to configure data pipelines, make them be repeatable, really drawing on private sources, hooking into AI services that are then doing that generation, transformation of data from various sources. You know, a lot of these networks of data, that's a big part of that. And then, of course, we have projects with sensitive data controls and things like that that we work with. But just to show a quick demo of this is a sample pulling from the VDEM data set where there's 2 graphs here looking at, you know, judicial versus legislative constraints, and then also judicial constraints over time. And these are just samples of a few countries that Dimitri and Michael selected when we were working through creating this demo. But with this dashboard within our tool, we can pull the original data and then look at really a huge variety of different visualizations. And these are things that really anyone can do on the fly to get a new insight to kind of play around with, okay, how does the data look depending on how you work with it. And you can see, you know, scatterplot, t-test, et cetera, all the various things that you would expect to be there. For this sample, it was adding one that, okay, can I visualize this, you know, geographically? So this is pulling in the VDEM data set and, you know, grabbing the country code. That is making sure we have the right code matched of how it's going to then place that on the map. And then really it's similar to what Michael was talking about this freedom of expression. You know, what does the average freedom of expression look like as we then plot this on a map? And you'll see that in a second when it finishes creating the chart. So this is pulling data real time from whatever data source we have behind. So this is not static data. This is something that then we're looking to have update in real time on the fly based on whatever the current set of data is for this. So now you see we have this map and okay, I have the colors, but what do those colors mean? What the demo is doing now is building a legend to be able to say, okay, what do those values actually look like for those different countries? And then it's going to, and then the demo adds it on to the side of the dashboard here. But then of course, one of the really nice things we have built into the platform is, okay, let's change a little bit of the distribution, the layout a little bit. So able to resource. So then one of the reasons I really wanted to show this is a platform that can't just be used for this project. We're focusing on like with this project as part of early access users, but this is something just to think about, as you're thinking about your projects as well. But then again, with this, okay, let's rearrange some things. Really want that legend to be much taller. So that's the next part of this is just being able to resize that, making the map wider, etc. And then also having the data down below. And these are all, again, these are tools that are meant to really bring more of these tools that have been in the hands of people setting up portals, websites, more within your hands is really the focus of this. And then kind of lastly, what kind of thought about as putting this together is, on the right there, okay, there's those country codes, but there's also, it's very quick and easy to change that to be the actual country names themselves. So that's kind of the last thing that's shown here. But again, this was something that I set up as I recorded it in 3 minutes. It was really quick in order to do this. It was just completely a recording of me doing this live.
And so the modeling components will come on top of
Yes.
it. So this
Yes,
already
that's right.
exists, right?
Yes.
So it just
This
goes on the
this
data.
exists now. That's
Yeah.
correct.
So we don't have to even do anything, it just does it. But then whatever models we want to add, that will be incorporated only into our instance.
Exactly. And really doesn't, that visualization tool itself doesn't necessarily care what the data is, where it's coming from. But now you as the domain expert, you can then take that and apply it and then visualize how you think makes sense. So I'll hand it over to Dimitri.
So, yeah, this is already exist. What Trix showed, and this is what we are planning to integrate into that model. So it will be our M3D public portal. And we are moving step by step. So this was the first step that Eric showed, and the final step will be the capacities in this model to model with AI-based tools the democratic development decline. So in different countries, in different regions, globally. So to illustrate and to give you a sense how it will be in the future, I just make a very small toy example of forecast of democratic development in America using Orange. This is the interface of the Orange software. If you Google it, you can Google it and install it. It's free. So it's software. It's not a data platform. So, but it's nicely built in a way that we want to have something similar in our data model. So it started with the data, download your data, the file, then you can select rows, select columns, then you can impute and process your data. Each step you can see what happened with your data. Then you can apply some models. Here I applied vector after regression modeling with forecasting. And you can have a model evaluation. Again, this is only 2 steps that we want to establish in our data model, like possibility for users to impute data, then to build models, then to evaluate models, and do it simultaneously. So you can, in online live format, change variables, then you will see what's changing the model. You can use different imputation procedures and see what's happened with the models. You can see actually what your model fits increase it simultaneously as well. So this is kind of, but we just plans to integrate more, actually, more possibilities, not only mutations, but building, for example, building indices, apply unstructured data as well, to integrate different data sets that does not exist here in Orange, does not have possibility, and so on and so forth. So just to have sense what you can do. So this is a toy example again. So I tried data from quality of government. I took here several variables that Michael already told, approximate, intermediate, proximate, some distant variable like economic one, geographical one, the social one, and he trying to focus the VDM index of egalitarian democracy. Fortunately, the quality of government doesn't have components, so that is why it's an integrated index. So it's just game visualization, for example, how our future portal can look like. Yeah. So I have data, I can choose the data, I can impute data using different procedures. Then I will get my forecast and get my model relation criteria, how model is good or not. So, and I can do simultaneously several models. Here I have two models. Just imagine that you have not two, but 3, 4, 5, 20, 12, 100 models. Yeah, and you can play with them simultaneously, trying to, and even more sophisticated, actually AI can do this instead of here I'm doing this, and actually AI have to do this. Yeah. So, and give you several models that are of the best fit. So here I played a little bit too with different methods, and I have two actual scenarios of future of American democracy. First is here pessimistic, they just collapse American democracy. Here's 2020, 3 or 4, and then it's going to the next 10 years of forecast, just collapsed. Yeah, so this is bad news. Good news that model is not. It's just rubbish. Actually, so that's why I tried another model that is a little bit better, but and it has some sense because we have the decline. Some hope. Okay, okay. So we have decline of American democracy, and this is the 2026 midterm elections. Yeah, and then we have just American democracy coming back. Yeah. So this is some hope. But again, it's no example. So just playing with variables, but it shows us some sense, some idea of what will our data platform will be capable of using.
Okay. Well, what time is it? Okay. Well, I guess I just want to say that we have an ambitious timeline of things that we are planning to do. We received 2 grants so far for the project, one from the Franco Family Foundation and another from Kellogg for this working group. And we've already submitted 5 other applications hoping to get funding for this. We also had an unsuccessful NSF application, but we're intending to apply again in February. We're aiming to complete data collection in November. We have RAs working hard on that. And then we'll be working on the 2 kind of neural network models to build an AI. And by January, hopefully we'll have a prototype of the AI. And we'll reapply to NSF. We're going to reapply for intermediate grants if necessary. Then we'll continue doing more extensive data collection and cleaning and harmonizing things to get together. Further model building next spring and summer. It looks like we're going to be applying for a Lucy Kellogg lab earlier than September. And then by September, October, hopefully we'll be able to have a public release of the data platform, and we're aiming for a conference October 15th to 17th. No funding for it yet. We have two applications in two different places to fund a major conference in which we present this platform, get feedback, and hear about what other people are doing that's germane for this kind of project. And papers from that conference would be massaged into papers that would be publishable and special issue of a journal such as Democratization. And then building kind of a larger project with a knowledge network that involves different kinds of training for different audiences and holding workshops to help people learn to do this, maybe offering a summer school, bring people in this, but anyway, a broad outreach to publicize the model and help people learn to use it and maybe spin off different things that we could do.